right. So we've been working with Taylor and Maclaurin's series, and we can identify x values to which the series converges, but given any arbitrary power series. How do we do this? So this is the question we're going to focus on. So the rest of this unit, and some things to consider is, how do you know if a power series converges? And then if we know that the power series converges, how do we determine the interval in which it is convergent? So again, let's try and visualize what it means to converge and on what interval. So here you can see that I've graphed for you the first number of terms in this power series here for 1 over 1 plus x squared, which you can recognize as a Taylor polynomial, and I've expanded it out to a 8th order Taylor polynomial of partial sums. And what we're going to do is we're going to graph this. Let's do this in a standard viewing window. And here's the first partial sum, and then the second, and now the third, and the fourth. And you can see that they're all pretty exact, and at this time it should be graphing there it is. You can kind of see it on the x-axis there. That's the actual power series that it actually converges to. So let's go ahead and zoom in and see what's happening outside of this interval of convergence, which we know this Taylor polynomial converges for values of x between -1 and 1. And again, here's the first partial sum, the second, and the third is being sketched in there, and now the fourth, and we should see now the actual convergent function coming in, and there it is. And you can see, let me identify where -1 is. Here's -1, and if you just go up vertically, you can see the partial sums do a fairly good job in between this window here from -1 to 1, and they of course get better, but outside of that window then they begin to fail. So this is what it means to converge, and you can visualize it in this manner.